Hello, good evening.
Good evening, sir.
Yes.
Good evening, sir.
Yes, Devanshik, after a long time.
Yes, sir. Good evening, sir.
Good evening. After a long time.
Yes, sir.
Why?
Sir had pre-final, sir.
Oh, great. You had pre-final exams.
Yes, sir.
How did they go?
Sir?
How did your exams go?
Sir, well, sir.
Okay, nice. What about others? Pravalika, good evening. Nadyasha, good evening. Tanish, Chandrakhan.
Good evening, sir.
Good evening, sir.
Okay. Have you gone through?
Yes.
1 second, Chilla. Yes. So, Adyash, I think you was absent for the last class, right?
Yes, sir.
Yes. Have you gone through the notes?
Yes, sir, I checked.
Very good. So tell me, what was the last question? Can you make it fast? Yes, I think we were solving. There are 6 periods of each working day at a school, isn't it? Correct? Am I correct? Okay. In how many? In how many ways? 2 same physics, 3 same chemistry, and 4 different math books can be arranged in a row so that books of same subjects are kept together. Okay, this is a permutation and combinations. Okay, look at this. Look at the question. How many ways? 2 same physics, 2 same chemistry, and 4 different math books can be arranged in a row so that books of same subjects are kept together. Same subject. Quick, 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 quick. Make it fast. In how many ways 2 same physics, 3 same chemistry, and 4 different math books can be arranged in a row so that books of same subjects are kept together? So 2 physics, 3 chemistry, 4 different math books. So math 4 different types. So math 1, math 2, math 3, math 4. Okay. So can be arranged. So this together, this together, this together. So what I told beta. So whenever you have same type of objects, so I'll be considering that as one unit. Okay, one unit here. This is a second unit. This is my third unit. Correct. This is my third unit. So this all these 3 books can be arranged in 3 different ways. 3 different ways. Okay, getting my point? So 3 factorial into look at it, it's a 2 piece nothing but 2 physics books can be arranged in 2 different ways divided by 2 physics are repeating, so 2 factorial into 3 C's, so 3 factorial. 3 chemistry books can be arranged in 3 different ways and 3 alike objects, right? So 3 factorial into 4 different maths, 4 different maths. 4 factorial divided by what? 4 factorial divided by 4, isn't it? Getting my point? Huh. Do we need to write 4 factorial by 4 factorial or simply 4 factorial? Tell me. Do we need to write 4 factorial divided by 4 factorial or 4 factorial only we need to write? Make it fast.
Only 4 factorial.
Only 4 factorial. Why? Why it is so? Why? Because 4 different mathematics books. So one math 1 factorial, math 2 1 factorial, math 3 1 factorial, math 4 1 factorial. Getting my point? So those who are absent, it might be completely new topic for you all. Like it might be completely it might looking completely different to you all. Make sure that you guys are doing you are revising the notes. Okay, 3 factorial. So look at it, 3 factorial, 3 factorial, 2 factorial, 2 factorial will get cancelled. 3 factorial gives me 6. 4 factorial gives me how much? 24. 24 6 how much beta? 24 6. 24 5 is 120. So 144. Correct? Isn't it? This is my answer. In 144 different ways, 2 same physics, 2 same chemistry, and 4 different math books can be arranged in a row so that same books, same subjects are kept together. Hope it is clear. Any doubts? Any doubts? Any doubt, guys?
No, sir.
Next question. So what was the formula? Yesterday I told you, beta, look at this here. If at all any, let's say that we took an example called noon. Okay, here, or you say moon. Look at it here. Moon can be arranged in how many ways? 4 letters. So 4 different ways divided by m is 1 m, 2 O's, so 2 factorial, and 1 n, 1 factorial. So this is how I'll be solving the questions of alike objects, permutations of alike objects. Okay, next. Okay, in how many ways can in how many ways can 5 girls and 3 boys be seated in a row so that no 2 boys are together? Look at the condition properly. Quick. Look at it, very simple, yeah, very simple, very simple. Look at it, what he has given to you all. In how many ways 5 girls, 3 boys be seated in a row so that no boys are together? Look at it, how many girls I have? 5 girls. Girl 1, girl 2, third girl, fourth girl, fifth girl. Okay, so 3 boys be seated in a row so that no boys are together. No boys are together. So boy can be seated here, and one boy can here, one boy can here. 3 boys. Getting my point? So in this, how many places I have for boys? 1, 2, 3, 4, 5, 6. In these 6 places, 3 boys can be seated, isn't it? What is the condition? No 2 boys are seated together. Okay. So girls arranged in how many ways? How many ways? So 5 different ways. 5 different ways. Girls can be arranged in 5 different ways. So 5 factorial. So 3 boys. Look at it here. 3 boys arranged in how many gaps? 6 gaps. So what is the answer? 6 gaps. I have. I need to select 3 places. So 6 C3. What is the final answer now? How many ways 5 girls and 3 boys be seated in a row so that no boys are together? So look at, first I selected. Perfect. I selected that 6C3. Okay. See, and we selected 6 places and arranged what? Out of 6 places, I selected how many places? 3 places. And arranging those 3 boys in how many ways? 3 different ways. I selected 3 places. I selected 3 places out of 6 places and arranged those 3 boys in 3 different places. So selection, NCR, arranging in factorial. Hope it is clear. So what is the answer now? So what is the answer? Total. What is the total? Find the number of ways. Total number of ways. Therefore, total number of ways is equal to what? 5 factorial into 6C3 into 3 factorial. Okay. So 5 factorial is nothing but what? 5 factorial, you write it as it is. 5 factorial. 6 factorial can be written as 6 into 5 into 4 factorial divided by 3 factorial into 3 factorial. Okay. So let's expand this 3 factorial into 3 factorial. Now look at this here. So 3 factorial, 3 factorial, 3 factorial, 3 factorial will get cancelled. So what you left with 5 factorial is nothing but 120, 6 5 30, 30, so 1, 30 into 4, 120, right? So 120 to 120, 144,000. So 14,400 is the final answer. Correct? Any doubts? Any doubt, guys? Guys, any doubts? Any doubts? Hello?
No, sir.
No, sir.
Very simple. In how many ways, in how many of the distinct permutations of the letter Mississippi do the 4 eyes together? 4 eyes not come together. We already solved this question, so you can solve this question very easily. Quick. Yes, tell me guys. Hello, how many ways, in how many of the distinct permutations? Distinct permutations are about what? Distinct arrangements. It's talking about arrangement only. Distinct arrangements of the Mississippi do the four eyes not come together? Four eyes not come together. Four eyes not come together. Answer is what? Licorice not come together, which is nothing. Total minus four eye come together. I mean, all eye come together. All eyes are together. Getting my point? Total. Total how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 factorial divided by how many repeating here? 4 factorial into
4 factorial into 4 factorial into 2
2
factorial.
divided minus all eyes together. All eyes together is what? All eyes together. So all eyes together, how I do beta? All eyes together. So first I write all eyes together like this. All eyes.
Sir,
Yes.
won't it be 8 factorial by 4 factorial into 2 factorial?
Yes. Very good. Look at it. Four eyes together. And what is the remaining thing? What are the remaining letters I have? What are the remaining letters I have? M. Yes. P. That's it. So look at this. Whatever the letters are coming all together, they'll be considering as one unit. And here how much? 7. So 7 plus 1, 8. Okay. So 8. So 11 factorial divided by 4 factorial into 4 factorial into 2 factorial. Those who have attempted, those who are attending the class freshly, you will not understand anything if you don't go through the revision lectures. If you do not go through the lecture videos and watch it and come to the class, until and unless you will not understand. Okay, please. So here, how many s are repeating here? 4 factorial. How many p's are repeating here? 2 factorial. Into all these four i's can be arranged in 4 different ways, isn't it? Getting my point? Divided by four i's are repeating here, so 4 factorial. So 11 factorial by 4 factorial into 4 factorial into 2 factorial minus 8 factorial divided by 4 factorial into 2 factorial into 1. Okay, so let's do this. Let's write together one second. Okay guys, 11 into 10 into 9 into 8 into, okay, 7 into 6 into 5 into 4 factorial divided by 4 factorial 2 factorial, okay, minus 8 factorial divided by 4 factorial. 8 factorial can be written as what? Into 1, in fact 4 by 4, this will be 1, right? So cancel out now. 4 will get cancelled. 4 factor will get cancelled. 2 ones, 2 fours. Okay. Now 4 factorial is nothing but what? 24. So this 4 and 6 will get cancelled. 24, right? 2 factorial, 2 fours. Now just multiply all this. So 90, 990 and 35 minus 28 into 30. Okay, 60, 84, 840. Isn't it? Yes, 840. So 990 into 35, how much? 990 into 35, 35, 5 9, 45, minus 45, 49, 3 9s, 27, 3 9s, 27, 29, 5, 6, 14, 3 6, 3 4 6 5, 3 4 6 5 minus 840. So this is what your answer is going to be. Just calculate this now. 0, 2, and 26. This is my answer, isn't it? Getting my point? No, I think 990 into 35. I think we made a mistake. Minus 45, 5
Sir,
45, 49. 3 9 is 27.
Sir,
27. Ah, yes, yes.
the total answer should be 33810, right?
Yes, yes, yes. That is somewhere I made a calculation mistake. 99 into 35, how much you got? Yes. I think 90, 990, 99 into 35, how much? 35, 35 into 100, how much? 3500. 99 घटाओ उसमें से. Okay. So how much you
Sir,
get?
34600.
Sorry?
34600.
34600 minus this one. So how much you left with now? 33810. This is what your answer. Okay. Clear? So if any calculation mistake, check it out, beta. कोई दिक्कत नहीं है, problem नहीं है, ठीक है? Basic calculation only. Hope you understand that. In how many ways of the letter of the word permutations? I think your CBSE in CBSE textbook also they have given the same type of question. Permutations. The question is, in how many ways? In how many ways letters of the word permutations can be arranged if words can be arranged if words begin words begin with P and end with S. Make it fast. Solve this question. What's the answer? That's what is the answer. Hello. Are you here? See, in how many ways letters of the permutations can be arranged if words begin with P and end with S? Yes, what is the answer, people? Can you hear my voice clearly? In how many ways permutations can be arranged? Word begin with P and end with S. Very simple. See, after solving many questions, you have to solve this. What begin with P, end with S. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 11 places, right? So 3, 6, total 12 places. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So word is ending with what? Yes. So this and this fixed here. I'm not disturbing. So the middle, in between letters, I'm jumbling here. They are fixed. This one and this one. P and S is fixed. You need not to disturb it all them. Get my point? So you need to jumble the letters in between P and S. So look at it. How many letters can be? How many letters are possible here? 10 letters. Right? Those 10 letters can be arranged in how many ways? 10 different ways. Okay. So how many letters are repeating here now? Look at this. So T, two T's are repeating. So by 2 factorial. Hope it is clear. Getting my point? So here P fixed. So 1 factorial. P can be arranged in one different way, right? So that is 1 into S can be arranged in one different way into 1. Hope it is clear, guys. Understood or not? So 10 factorial divided by 2 factorial is my final answer. Very simple. How simple it is. Getting my point, children? Hello. Here, in how many different ways of the letter permutation can be arranged? If the word begin with a P and end with S. Clear? Any doubts? Any doubts?
No, sir.
Guys, any doubts? If you have any doubts, just ask me the question. See, don't feel shy to ask the question, no matter what. Even it is easiest, even it's a silly doubt, you can ask me. Don't feel scary to ask it. Okay, please kindly ask the doubts. Understood? Pravalika, Adyasha, those who are absent,
Yes, sir.
please kindly
Yes, sir.
go through the notes, kindly go through the lectures. You will understand it. If you are not able to understand, please kindly let me know. No problem. We will have extra classes and we can clarify your doubts. Clear? In how many ways letters of permutations can be arranged? If words begin with a P and end with S. Okay. So next, same question here. If words begin with, this is the first question. If words begin with, first question is what? First question. If words begin with a P and end with S, that was the first question. Same question, same letter, I mean same word, and vowels are together. Vowels are together. Then in this case, what would be the what is the number of ways? Permutations. All vowels together. What are vowels I have here? What are the vowels? E, U, A, I mean all the vowels. A, E, I, O, U. Let's write. Why confusion again? Let's write A, E, I, O, U. Vowels. Okay. All vowels together. Apart from vowel, how many letters will be there? So I'm blocking this. Okay. And the remaining how many letters will be there? Whatever the question he has given. Whatever the question he has, whatever the condition he is given to you, please block that. Vowels are together. So I'm blocking this as a one unit. Correct? So how many letters will be there? How many letters? 1, 2, 3, 4, 5, 6, 7. Total 7, right? 7 plus 5, 12. I have 12 letters here. In the word called permutations, I have 12 letters. So whatever the condition he has given, I'm just considering that as one unit. And here how many letters will be there? So 7. Right? So this 7 plus 1. How much? 8 factorial divided by how many repeating here? How many repeating here? How many repeating? 2 I mean 2 T's are repeating, correct? 2 T's are repeating, 2 factorial. Getting my point? Into these 5 different vowels can be arranged in 5 different ways divided by no repetition, only 1 factorial. Hope it is clear. Is it clear with everyone, people? Is it clear?
Yes,
Yes,
sir.
sir.
So into 5 factorial. Calculate this, whatever the answer is going to be. Calculate that. Very simple multiplication only. Please do calculate that. Next question. Third condition is there are always four letters between P and S. P and S. Make it fast. Solve this question, guys. Yes, guys, tell me what happened. I don't find answer from anyone. Yes, Adesha, Devanshika.
Yes, sir.
What happened? What is the condition given to you? There are always 4 letters between P and S. Okay, so how many letters we had? Total 12 letters, right? So P is the first one, second, third, fourth, 5, 6, 7, 8, 9, 10, 11, 12. So there are always 4 letters in between P and S. Is nothing but देखो 1, 2, 3, 4. Then S must come here. Correct? Correct? Huh. If I fix this, how many blanks I left with now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this 10 blanks can be arranged in 10 different ways. 10 different ways. Divided by, what is the repetition? Which letters are repeating here? 2 T's. So T's are repeating. So by 2 factorial. All right. Huh. How many ways will possible like that? How many ways possible will, how many ways possible? See, I didn't tell you that the word must start with a P only. Getting my point? The P can come here, and yes, can move here. Still have 4 letters gap in between them. Getting my point? So one possibility here. Then this can come here. This can go here. Second possibility. Third, fourth, fifth, and I think 1 second. Total, how many possibilities are coming here? Check. P is here and S is here. If P moves here, this is one possibility, right? Second possibility is here, and second possibility going here. Next, this can go here, third possibility, and here, this can come here. Fourth, fifth, sixth, and this can come here, seventh. Getting my point? Sixth, seventh. How many possibilities total? 7 possibilities like that. Total 7 possibilities where I can have 4 letters in between P and S. You can arrange in 7 different ways. Understood my point? People understood or not? How I wrote 10 factorial by 2 factorial into 7. What is the reason behind writing 7 factorial there? Yes. 7 different ways. Next, look at this here. Who told you that P must be the first and then second S? There are chances of having S first, then second P. Still you have 4 letters in between. So the word can start with P or S. So into 2, there are 2 chances, right? The word can start with P and you can have 4 letters in between, and word can end with S. Getting my point? And word could start with S. There are 4 letters in between, and P and ending with P. So total 2 possibilities. In 2 ways possible, so into 2. So this is my answer is going to be 10 factorial divided by 2 factorial into 7 into 2. Whatever the answer you get, that is what your final answer is going to be. Clear? Any doubts how I wrote 7 here? How I wrote 7 here? Understood? Check. First possibility. Second. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes. So 2 and third possibility here. Fourth, fifth, sixth, seventh. Getting my point? Total 7 possibilities like that where I can have 4 letters. So this is my final answer is going to be clear. I think some of you are having still doubt. Guys, what happened? No doubts? Shall we go for the next concept? Guys, any doubts? Understood how I wrote 7 there and how I wrote 2 there? Understood or not, guys? Tell me, yeah, you have a right to talk to me. I don't know what happened to you all. You can talk to me freely. Adesha, any doubts? Adesha, any
No, sir.
doubts? Devanshika, Ravalika, Niyati, Chandrakant, Tanish.
Yes.
Next. Next, we'll go for circular permutations. Circular permutations. Circular permutations. Look at this here. First, the condition. I'm writing the condition. The circular permutations in which clockwise and the anti-clockwise arrangements give rise to different permutations. Different permutations. Take a look at this here. What is the meaning of this? For suppose you have look at this here. 1 second. Wait. Okay. The circular permutations in which clockwise and the anti-clockwise arrangement give rise to different permutations. Let's say that there are people X. You say that 1, 2, 3, 4, 5 people are sitting in a round table, circular way. Getting my point? Huh. They can face in anti-clockwise direction as well as clockwise direction as well, isn't it? They can face in clockwise direction as well as anti-clockwise direction. They can be seated like this, Rababu. They can be seated like this as well. They can face like this as well. Both sides they can face. There are two possibilities, isn't it? They can sit however they want. So there are chances of sitting in clockwise direction and anti-clockwise direction. It gives you what? It gives you what? Circular permutation. The condition is what? The circular permutations in which clockwise and the anti-clockwise arrangement give rise to different permutations. Give rise to different permutations, isn't it? So whenever you write, whenever I get this type of case, I'll fix one guy here. I'm fixing one. If I fix one person, if I fix first person, whatever the rest, whatever the rest, I'm fixing one guy. I'm just arranging rest 4 guys. So how many ways I can arrange this now? 4 factorial ways, isn't it? I'm fixing one guy. So whenever you have a condition called the circular permutations, whenever you get circular permutations concept, you have to fix one guy, and whatever the remaining, you have arranged that in a different ways. I just left with 4 guys after fixing one guy. So I'm arranging those 4 guys in different ways, such that I could write that in 4 factorial. Getting my point? Understood my point? Understood or not? If I have 10 members, Babu, I'm fixing one guy. Remaining 9 people, I'll be arranging in 9 different ways. That is what I'm trying to say. All right. When this condition applies, a circular permutation in which clockwise and anti-clockwise arrangement give rise to different permutations. Getting my point? When you are sitting in clockwise and when you are sitting in anti-clockwise direction, and when it gives you different permutations, in such cases, I'll be applying the formula called what? N minus 1 factorial formula. Everyone write the note here. If we have n things, we will be having, if we have n things, we'll be having how many? We can arrange in n minus 1 factorial ways. N minus 1 factorial ways. Getting my point? Yes, guys, understood? If we have n things, we'll be having n minus factorial ways. Getting my point? If you have n things, we'll be having n minus factorial ways. So first, suppose when it is possible, guys, if you have circular permutations in which clockwise and anti-clockwise arrangement give rise to different permutations. There is clockwise as well as anti-clockwise. In such cases, we will have different permutations. In such cases, we will have different permutations like n minus 1 factorial ways. Okay, we will solve the questions, you will understand. Look at this now. Let's say you have second case. You have a second case like the circular permutations. The circular permutations in which clockwise and the anti-clockwise arrangements give rise to same permutations. Same permutations. When you have different permutations, what is the formula? N minus 1 ways. When you have same permutations, what is the formula? In this type of cases, then number of ways in which n different objects can be arranged in n minus 1 factorial by 2 ways. Getting my point? So what is the example? The world famous example you have, like, you have a necklace. Okay, you have a necklace. So look at this here. If you are, wearing this, let's consider that you are wearing this. Okay, imagine, please, you have a necklace, you are wearing that. Okay, it gives you what? In factor. I mean, like, it gives you 1 second ago. Even you wear in whatever the direction you want. Look at this, you are wearing in this direction, let's say that, and you tilt it, rotate that and wear it, okay, rotate that and wear it. What happens? Still again it shows the same color, right? Let's say that you have green color here, let's say you have blue color something. Okay, let's say that again you have some color again, let's say you have pink here. Okay, something. Okay, if you have wore this, whatever the permutations you get, same permutations, same number of arrangements you will get when you tilt and wear it. Getting my point? Are you guys able to understand what I'm trying to say? What I'm trying to say here, you take a necklace, you wear it, and just take that necklace again, tilt that. I mean, usko घुमा दो एक बार, ठीक है? Tilt that and wear it again. It gives the same permutation. Doesn't make a sense at all. Doesn't make a change at all. Getting my point? So that is the reason I'm writing n minus 1 factorial by 2 here. Why we are dividing with that 2? Why we are dividing with the 2? I'm just doing 2 experiments here, first and second experiments. Both are giving me same experiment or not? Both are giving me same experiment. So look at it, 2 by 2 is what? 1 here. That's how. Let's say that you're doing experiment, you're getting 4 same results. Getting my point? And what I'm doing here? Dividing by the same number of times. What I'm doing, when I look at this here, I'm just doing this experiment and second experiment. In both ways, I'm getting the same result. That is the reason divided by 2 I'm doing here. Hope it is clear. Even you wear in normal way, or even you wear in a ulta, tilt it and wear it again, you are going to get the same result. That is the reason n minus 1 factorial by 2 ways. What is the condition here? What is the statement? Circular permutation in which clockwise and anti-clockwise arrangement give rise to same permutations. It is giving you what? Same permutations then the number of ways in which n different objects can be arranged in n minus 1 factorial by 2 ways. Hope it is clear. We will solve a question, you will understand it. You will solve a question, you will understand it. A round table conference is to be held among 20 delegates. What do you mean by delegates? Belonging from 20 different countries. In how many can they be seated if two particular, what do you mean by delegates? Two particular delegates are, first one, always to sit together, and next, never to sit together. A roundtable conference is to be held among 20 delegates belonging from 20 different delegates is nothing but representative. It a representative, a person who organizes, a organizer, representative. Getting my point? Like, couple of people is a team leader, you say. Okay. There are 20 delegates belonging from 20 different countries. In how many ways they can be seated if two particular delegates are always sit together and never sit together. Always sit together and never sit together. Guys, look at this, very simple. They are sitting like, look at this, 20, 1 second. So always to what he is talking about, in how many ways can they be seated if two particular delegates are, look at this, two particular delegates. I'm selecting these guys in one box. Then how many people will be there? Rest how many people? Guys, rest how many people? I'm taking this as one unit. Sit together. Okay. Rest how many will be there? Total 18 members. 1, 2, 3, 4, 5, 6, 7, 8. Something like total 18 places, isn't it? Total 18 members will be left. Guys, 2 I made in one box. Remaining out of 20 people, there will be 18 left. Correct? Isn't it? Hello guys, are you able to understand or not? So one people, one unit and 18 units. This 1 unit and 18 units, total 19 units. Total n is what here now? What is n here? What is n beta? What is n now? N is equal 19. So n minus 1 factorial, which gives me 19 minus 1 factorial, which is nothing but 18 factorial. Getting my point? This is what? Always sit together. Always sit together. Understood? Understood or not? In how many ways can they be seated if two particular delegates are always sit together? I'm making sure that two delegates are sitting together, arranging in one box. Rest. How many? Rest 18 people will be there. This 18 people and this one, sitting two people in one group. Getting my point? That particular group and this 18 members group, I'll be considering as 19. So n becomes what? 19. So what is the formula I'm using here now? N minus 1 factorial, which gives me 18 factorial is the answer. Sir, why you are using n minus 1 factorial here? This concept. If you have n things, we'll be having n minus different ways, n minus 1 factorial different ways. When it is possible? It is possible if and only if you are having different permutations. They can sit in clockwise direction and anti-clockwise direction as well. But you are getting what? Different permutations. In such cases, I need to use n minus 1 factorial formula. Correct? In such cases, I need to use n minus 1 factorial formula. Very simple. Okay. All right, children. Any doubts here? Any doubts? Guys, any doubts? Hello? Any doubts?
No, sir.
Next, never sit together. Never sit together is what? What is the never sit together? Guys, just know, common sense. Just now we solved this type of sums. Never sit together answer is what? How can this is the first answer? What is the second answer? Never sit together. Total minus sitting together. Total minus sitting together. Total how much? 19 places, 19 different arrangements. So 19 factorial minus sitting together. Sitting together is what? Sitting together, beta. Tell me. Sitting together. Sitting together is what? 18 factorial into they can sit in any of the ways, right? Getting my point? Sitting together. So 2 into 2. So this is my answer is going to be never sitting together. Answer is what? Total minus sitting together. Total 19 factorial. Sitting together is what? Sitting together. 18 people can be arranged in 18 different ways. And they can sit in what? In 2 different ways. Hope it is clear. They can sit in either anti-clockwise or clockwise direction. So total 18 factorial into 2 different ways when they sit together. Hope it is clear. Any doubts, people?
No, sir.
Okay, this is how I'll be, solving this type of circular permutation questions. When you have clockwise and anti-clockwise direction and different permutations. When you have clockwise and anti-clockwise direction and same permutations. Okay, in such cases, if I have different permutations, I'll be using n minus 1 factorial. If I have same permutations, I'll be using n minus 1 factorial divided by 2. So we will solve the question in next class as well. So this is what today's class is all about. And the next class, please go through the notes and come to the class. Permutation is all about reading the question properly, thinking in different ways. There is a no such rule that you have to solve in this way only. You can solve in any different way, but your answer should match with that particular question. Getting my point? Your answer should match with your options. You can't have, you can't go with any number of any method which is not suitable. Okay, so please, it's all about how you are thinking, how you are understanding it. Permutation is more likely relating with our daily life examples. If you are relating really in a well manner, it is very easy to understand. If you're not understanding it properly, questions will be very big, but writing answer is takes fraction of seconds. Within seconds you can write the answer if you understand the question. All about understanding the question. Okay, please kindly understand that, go through the notes and solve the everyday homework questions and come up with a revision in the next class. Until then, bye bye. Good night. Thank you. You may leave now.
Thank you, sir.